Buongiorno a tutti e grazie per aver resistito fino a giovedì. La platea in genere il giovedì è una platea selezionata, senza niente togliere a chi ha dovuto scegliere di rientrare.
I'd like to thank you all for being here. I'd like to go back to what Antonino Tranquida said. The problem is one that's increasingly felt, particularly in the last few years, with the evolution in viticultural techniques, and also following some changes in market dynamics. We have samples sent by our customers who decided to become part of our research projects. Over 80% of these wine samples has a content in terms of quercetin aglycone that makes them candidates for drug problems, and that not just in central Italy or Tuscany, but in the north and in the rest of the country as well. And here you see that glucoside, this is quercetin glucoside, and glucoside is a reservoir that can give problems, particularly at 3 milligrams per liter. The phenolic profile of Sangiovese shows a clear-cut prevalence of the quercetin glucoside among flavonols, and the release is also pretty quick. You find over 50% during maceration, and on top of that you have a proportion that is settled already. Glucoside will face hydrolysis as Professor Moutonnet clarified. One of our intents is to study the influence of surrounding variables and operational variables on this phenomenon. In 2004, thanks to the assistance of the Experimental Institute of Arezzo, we did lab vinifications, just a few liters per each variety, to study quercetin. At the beginning of the following harvest season, the total quercetin was particularly high in Sangiovese, glycone and glycosides alike. Now let's go back to the project. From a purely experimental perspective, the project aims to attain certain goals through three preliminary steps. The first is an acquisition of data of characterizations of flavonols between grapes and wines, Sangiovese being the variety. And then the techniques and the initial grapes will be evaluated as to their incidence on the amount of quercetin in the wines. And also, we will also assess the effects of different winemaking practices and treatments, with the final purpose of organizing an analytical monitoring service for the chain to reduce risks as much as possible and improve quality. I'd like to remind everybody that the project was started in the summer of 2016, and it should come to a conclusion in the first half of 2018. So these are only preliminary results, and they will be supplemented as we learn more about the subject. Now, we already see interesting things. There's an evident role on the part of the early stages, early steps in the aggregation of the quercetin sediments. When you analyze the wine, you obtain better results than, well, compared to analyzing samples that were filtered at low porosity levels. That should prompt us to think that in most cases, in the wines, you already have some microaggregates that have formed, which are subject to further growth and precipitation, and which are an indication essentially of the phenomenon underway. We characterized analytically the wines of 2014, 2015, present in the project leaders' cellars in July 2016. This is the chart resulting from that characterization. The Sangioveses, the vast majority, are positioned to the left of the plot, analyzing the main components. However, while 2014 Sangiovese tend to cluster together, those of the following vintage are more scattered, and their quercetin concentrations are more variable, with non-micro filtering size fractions. With the highest figures, most of the glycone present is already in the form of a microaggregate. As far as the international varieties are concerned, Merlot and Cabernet Sauvignon, namely, we also have Petit Verdot and Syrah. We have higher flavanol concentrations, generally speaking, and the fractions that we find are almost entirely screenable through a microfilter. So probably these are not going towards an aggregation phenomenon as the rest of our wines. Now, this is quercetin aglycone. On the left-hand side, you see the box plot for total aglycone. And here you see a relevant difference between Sangiovese 2014 and Sangiovese 2015. And here you have Merlot and Cabernet Sauvignon and the other varieties. However, if you focus onto the part that could be microfiltered and that is not aggregated yet, the differences are not so evident, with the exception of Merlot, where concentrations are different from that of the rest of the wines. This is approximately 2 milligrams per liter. There are no differences, so the entire amount of agricone should be regarded as something that you can pass through a microfilter successfully. Now, looking for explanations that would account for these phenomena, we found a blatant interaction between the elementary composition, in other words, the composition in terms of metals and other elements, with the concentration in total flavonoids. As Professor Moutonnet mentioned, this might lead us to think to some properties of flavanols to have a role in interacting with metals, or perhaps the activity on the part of certain metals to catalyze oxidation. We studied 7 out of the 90 wines we had initially analyzed, also studying their phenolic profile. This is the result of the PLS, where we tried to correlate the composition in terms of polyphenol variables and metals and so forth, and the content in terms of flavanols. There's a pretty evident characterization based on the vintage. These are 7 Sangioveses, 3 from 2014, positioned to the left of the chart, and 4 that were made from 2015 grapes, all on the right. And you see the tannins, the pigmented tannins and all the rest. Now, on top of confirming the importance of the interrelation of the metal concentration with the flavonoids, we also see another evidence that should be further studied again with respect to the different amounts of the various anthocyanins. Particularly in 2014 wines, there are higher proportions of quercetin glucoside. This is an analysis of a sediment that was left in the vessel after wrecking a Sangiovese. This sediment shows that the largest proportion of the substances in the dregs is made up of quercetin, but that quercetin comes with low proportions of camphorol and isoramnitin at concentrations which should normally be very low, below sometimes the ability of the instruments to pick them. In this case, they seem to participate in the phenomenon of precipitation, so much so that you can even doubt that they might be the key cause. While myricetin, which is found in higher proportions in the samples taken at the winery, around 8 to 10 milligrams per liter, it doesn't seem to take part in this precipitation phenomenon. The second stage, the second phase of our project started with the monitoring of the grapes picked throughout the designation area. The variation in quercetin levels found, and in this case it's quercetin glucoside, span between just in excess of 60 to over 180 milligrams per kilogram. 12 vineyards out of the total, those in ochre, are those of the project leading company, where we had created experimental plots testing different leaf thinning techniques. The three purple bars are the plots from where the grapes were taken for vinification purposes. There is also a concentration in quercetin glucuronide. Quercetin glucuronide is another important compound which is generally found in proportions which are generally 1/3 that of quercetin glucoside. The tests carried out at Coldorcia on the leaf thinning parcels were basically concentrating on 2 vineyards. In turn, they were subdivided into 2 plots based on the rootstock clone, and in each half they carried out early leaf thinning and leaf thinning at veraison. So the early leaf thinning was around fruit set time. And then we had a control. So we have different variations. The variance analysis shows differences which, although they are not significant in scientific terms, they are still there in terms of quercetin glucoside, and are as expected. With early leaf thinning, the prevalence is higher and lower in the other samples. In the other case, the quercetin levels was different, and that indicates that the synthesis of these glucosides is taking place at different points in time. In parallel with that, we did not see, at least with our test conditions, any significant differences pertaining to the average weight per berry. The late lift thinning seems, however, to be conducive to a significant difference. It is significantly higher. Once the general composition of the grapes had been acquired and the flavonoid composition was also documented, we tried to extrapolate a model for forecasting purposes. This was too weak, and so that demonstrates that there are other factors which are not the acid or sugar concentration or polyphenols, that other factors, I was saying, that have a more specific role in influencing flavonoid concentrations. In any case, as a general indication, the parameters that are generally positively correlated with the concentration in quercetin are anthocyanins, polyphenols, and the Palmer's to juice ratio. With respect to this model, the faraway samples are those in the project leaders' vineyards, where the lower quercetin prevalences are found, and the lowest are the 4 in the control vineyard. The goals of the experimental vinification were essentially to observe the evolution of quercetin over time and to test the effect of different winemaking strategies, and also to obtain material to be used for further testing. These are the characteristics and the strategy with the different plots. There was one facing north, while the other 2 belonged to Col d'Orcia and were facing south. Look at the soil and climatic characteristics and the elevation, and also what we did in terms of leaf thinning. The characterization of wine samples based on basic analysis, the routine analysis, the phenolic profile, and the rest, is plotted here in this chart, and the samples are identified through their content in quercetin glucoside. As you can see, the 2 Col d'Orcia samples, this one, 141 milligrams per kilogram of quercetin and 245 of sugar, approximately 1 week before harvest, and the ITQ, which was 56 and 218 respectively, are marking the 2 extremes.
In terms of characterization, we also have the BE sample. Despite the fact that it has a higher quercetin content, in general, it is at the center, in the middle of the plots of samples. So I would say that it is more bending towards anthocyanins due to the phenolic compounds. The ways we examined that entailed 2 approaches. We had basically 6 vinifications, and I would like to thank so much Antonino, because Col d'Orcia not only has an institutional role, but also sees to a number of things for the others in the project as well, including these experimental vinifications. In blue, you see the low intensity tests, LO, and in red, high tests, HI. And that was done in function of a more marked extraction. We use enzymes. In one case, they were not used, and then you see 2 grams per quintal. Temperature of fermentation is between 22 to 25 degrees for low thesis and 30 to 32 for the high tests. And maceration in one case is double as long. And then the other practices are standardized and the same for everybody. We also see that we have an analysis of a number of results here, and what you see there are results for days before maceration, and then also in relation to the evolution of the wine. You have MO3, MO5, and they are days of maceration. SV is racking, VO is the moment which precedes the further rackings, VT2, 1, 2, and 3. So one is devatting the former, and now we have the racking offs. As Professor Moutone explained, we have interactions with flavonols and interrelations especially, and that has been ascertained by us too. We saw that basically a model solution with 12 of alcohol content and buffer 320 has a certain behavior vis-a-vis quercetin, while if you add anthocyanin, then solubility increases, and we managed to dissolve 5 milligrams per liter of quercetin glycon in a solution of 180 milligrams per liter of anthocyanins. So this is the reason why we follow the development of tannins and pigments. You have graphs that depict the development of these factors in multi-factor analysis with reference to the 2 maceration techniques. We see that pigments are extracted in a more effective way in the case of the marked maceration and strong maceration, and already after devatting we do not have significant differences, but we do have a difference for tannins where you have a concentration which is double as much in that case and which is persistent over time. With reference then to what you see on the right is results for the vineyards, and in this case we have a difference in terms of pigment that is detected over the course of time and then diminishes with the various racking offs, and you still have a concentration in tannins which is highly differentiated in relation to the 3 vineyards of origin. And with reference to the composition of the pigments, we also observed that the free fraction of anthocyanins is typical in the less marked maceration phases, while in the more marked ones the formation of pigmented tannins is definitely higher. And now we see how quercetin behaved. Here we have a collection point which is an extra one, which is DP, which is just after pressing, and with reference to the difference in terms of the vine of origin, you see that the difference remains there down to the very last phases, and we find it especially initially in terms of glucoside. These graphs have to be interpreted in a dynamic way. There is a dynamic balance between the fraction that has been extracted from the skins and fraction of glucosides that hydrolyzes and fraction of glycans that follows hydrolysis, and then the precipitation during the phenomenon. So you have to interpret and read these things together, one parallel to the other. Evidently, in the vine that was poorer in quercetin in the beginning, we find this situation whereby there is a proportional difference, which anyway is persistent over time. It lasts over time. Clearly, you have an effect following the origin of the raw material. Then with reference to vinification, we have differences which are fairly clear in the phase of maceration in these high theses, and aglycone, which consequently increases, shows a difference between the two moments of the devatting and racking off. And then you have also a reduction whereby there is a reversal in the trend in the last phases of the wine, while in softer maceration thesis, this is something that continues. I can tell you that in bottled wines that have just been analyzed, we find again this trend, this continuation of a trend. We also talked about the contribution of the pressing and the free run wine, and this is what you find here in terms of glucoside in the pomace. In the high thesis, you have the extra 7 days. So glucoside had 7 extra days to hydrolyze, and it is lower. But anyway, concentrations are balanced when compared to that of the wine. So evidently, this element of pressing does not have a significant impact. With reference to aglycone, in the high thesis, we have an enrichment which is significant in terms of the aglycone fraction of quercetin, which I believe is an evidence which we have to take into account. Now, the microfiltrable fraction follows exactly the same development of the total one that was previously identified with very minor differences. When concluding the test, we made a sensorial evaluation, 22 operators and experts working in the comprensorio of Montalcino, used a method whereby they received blind, of course, randomized, sequenced samples. You have to conclude, Stefano. Differences are interesting. High thesis certainly receive a better evaluation than the low thesis. What I think is important is that there are no significant differences between the defoliated thesis and the early defoliated thesis. In some instances, the performer is favored. And this is an example at making an attempt of having predictive indexes, and this after racking off. Of course, we talk about attempts here because we are still working with a few samples and attempts and tests of vinification. We see that post racking off, we already have a number of indications in terms of possible risk areas, and at the same time, we also have this correlation. I would like to emphasize again that this is just a preliminary phase of our work. We made a first set of enologic tests and used the wines of the experiment in an early phase so as to be able to find certainly residues of glucoside, and we also subjected them to acidification tests and added products that potentially could have a protective effect also vis-a-vis the advancement of glucoside. And indeed, we wanted to see over the course of time, possible differences, which you see there. Each thesis is made of a group of 5 bars, and the first one is the first one of low and high tests. Then you have S1 low and high, and so on and so forth. And these are the reductions in terms of quercetin glucosides. And you see that it hydrolyzes. There were no treatments that had an effect whereby you had really an impact on the phenomenon, even though the phenomenon, it seems that there is a slowdown due to cold, and there is an impact also on acidification, even though it is a slight one. And with reference to quercetin aglycone, we have first of all to evidence that there is a different situation in between the low and high tests, and in the high thesis, the balance between hydrolysis of glycosin and precipitation is again balanced, and we see a number of effects here of cold, which favors precipitation. We also have a trend here in acidified thesis to have a slowdown of the phenomenon. So we could assume that alternating thermal cycles could accelerate the phenomenon. Acidification could slow it down. Obviously, as I said, this is just halfway through the project. We continue observing all these tests. New monitorings will be done on grapes and wines for the 2017 harvest. Possibly we will focus especially on winery productions rather than experimental vinifications, and we can already now start and set a new series of tests in relation to treatments with protector colloids, protein products, oxygen, and many other things. And this has just been prepared, so it has started. We will see what we can obtain from that. Thank you very much for the attention.